A while back, I dismantled an old Eris MTA unit and recycled the rest of it. I got it out of the bin at work and tore it apart, showed you guys what was inside of it, and threw the rest of the unit back in the bin. But I did hang on to the battery pack, and today I think I'm going to open that battery pack and see if I can find another use for it. And I'm thinking Bluetooth speaker. Let's check this out. Today I have one of these battery packs. This is a backup battery from an Eris MTA unit that was used by cable companies to power up their telephone MTA unit, which is the analog telephone unit that the cable companies use. A while back I found one in the recycle bin and I took it apart and showed you guys that. I hung on to the battery pack on it because I figured this has probably got some components in here that I can use. I'm thinking probably what's inside here is some 18650s. We look at the specs on it, it's 8.4 volts, 4400 milliamp hours. So I'm thinking it probably has two in series and then another two in series and the two of them placed in parallel. So they're probably 2200 milliamp hours each cell, because I think I can probably reuse these cells for something. So these things open up pretty easy. Just take your side cutters and just clip them at the weld points. We'll take off these stickers so that they don't impede us opening this up. And then we'll see what goodies we have to repurpose. I have a couple of things in mind. Besides powering flashlights, which I've done before with cells that I've taken out of, these came out of a battery pack. But I have another idea for this, if it will work. Green, these ones are green cells in here. Just got to get this one last weld open in the base here. Try not to short out the little circuit board because this will be live. I don't need a lithium battery pack going up in flames in my hand. Okay, there we go. Okay, there's the pack in pieces. There's a little circuit board in here, and I was right, there are 4 cells. Look away at the cabinet here. It looks like there's a the battery should actually just pop out of this thing. They're probably glued in place. Or taped, more than likely taped. Here we go. Okay, so here's the cells. We'll take a look at how these were put together. Well, these may not even be any good. They've been kicking around here for a while. But we'll check the voltages on them. See if the cells are any good. So what we've got here is we've got a white wire going down to these 2 cells. These look like they're in series actually. Those 2 are in series. That looks like series as well. Okay, here's how they've wired these up. So these two cells are in series, which gives us their 8 volts, and these two cells are in series, and the negative terminals are both connected to this little circuit board here, which is going to have the charge circuitry on it. And I bet you the two of them are connected together in parallel with each other. So if we look at how the 4 cells were arranged in the battery pack, we'll find that we've got our 4 cells. And these two are connected together like that. And then they're connected together this way. This is the positive terminal, and this one is the negative terminal feeding out. So that would make this side of the battery the positive side. This is the positive side here. And this one here is the positive side here, which makes that one the negative side, and the negative side, and the negative side, and the positive side. So by connecting them this way, you've got your 4.1 volts, 4.1 because that's what the average voltage is of a lithium cell when it's fully charged. 4.1, 4.1. These batteries are connected in series, so you have 8.2 volts. And the same as on this side. So these are now treated as two 8.2 cells that are connected in parallel with each other. So that doubles the capacity. So each one of these cells is 2200 milliamps and 2200. Right now, when you put two cells in series, you don't increase your capacity, you increase your voltage. So two 2200 cells in series is still 2200 milliamps. Same with this one, but when you put the two of them in parallel, you double it to 4400. That's your capacity. For charging, it's a little bit different. So what they did is they connected the two additional wires here. These connect together at the charger, and this becomes a common mode, or think of it like ground. On charge, there's two separate charging voltages that charges as the battery. You've got between ground here, these terminals here will go to your charger. Okay, this one becomes your negative charge, and this one's your positive. Your charger in a simplified way of drawing the charger would be, and obviously a lithium charger is a little more than a simplified charger, but if you want to simplify things, you've got your power transformer and you've got a center tap, and the center tap is your ground point, and then you've got one that goes to a diode this way, and you've got the other side that goes to a diode the other way. Okay, now you've got a positive and a negative supply, which would then be taken down to your battery terminals. I didn't draw that the right way, I don't think, but wasn't paying attention. But anyway, that's the simplified way of how the charger works. You've got a positive charge circuit, and you've got a negative charge circuit with respect to a common, and the common is what's connected to these two outside terminals on the battery. So you can charge the cells independently, but you still, when you draw on the power, it's fed between just the positive and negative. The end sides here, the midpoints, are not in the circuit as far as the circuit is concerned when you are using it as a backup source. That's how these batteries are connected in this charger. A little more complex than that, but that's how it goes through from that charge controller. Positive and negative. So that's a positive terminal, that's a positive, that's a negative, negative. That would make that positive and that one negative, and vice versa. That one negative, that one positive. These two were connected together at this little charge board and power supply board. This would have more than the charge controller on it to charge it up. It would also have the power supply to power the unit up, to shut it down when the voltage dropped down to a specific voltage. But that's beside the point. That's not what we're interested in. We're interested in these cells by themselves. And unlike what I've done in the past where I've just ripped the terminals off, in this case I'd like to keep these tabs on here because I want to be able to solder them to something. So I'm just going to cut the tabs so that I have independent cells. So I can keep that one as a complete cell, 8 volt cell. I'll keep those two put together. But on this other one here, I want independent cells because I have a project that I'd like to put this thing into. And first I want to see whether I'm able to power the project up with just one cell. Yeah, Samsung 18650 2200, right? 22, so that's 2200. The project I'm going to try and make work with that is this little Bluetooth speaker that I built a while back that's of course powered with an external supply. I don't know whether the amplifier will run on the lower voltage or not, but we can find out quickly here by just connecting this thing up. So, and if it does work, I'll put the cell inside the battery pack, or inside the cabinet. But first, let's I'll just cut this cord here. What the heck? I don't need it that long. And we'll try connecting this up to this cell and see whether the speaker works off of a single cell. Because if it does, then I have a couple of options. I can cut it here and just have it as a single cell, and I've got a power a charger that came out of one of those battery units, and I can just put this inside the cabinet so that the DC plug, you would plug a USB charger in here to charge up a single cell, and just using this here as the buck down converter to charge the cell. So let's see first of all whether this speaker can be powered up from a single cell. I think it probably can. And then if that's the case, I'll go about putting this inside the cabinet with the exterior of this sticking out through the slot here to charge it up, and the power switch here will then be able to turn on and off the battery to control this unit itself. So we'll just connect the speaker up to, now this is going to give it 7.2 volts, so I want it on 3.8, so I'm just going to take it off of a single cell, and we'll see whether this looks like it's going to power up. Let me pair my phone to this and see how it sounds. So I've paired my phone to this CSR, what did I say it was? Anyway, CSR 8646, I think is what it said. It's, oh, get out of here, play. Yep, it works. It works. So now we know that this unit will operate just fine off of one cell. So the next thing is to break it down to one cell. I'll just use this one over here because I know what the polarity of this one is. It's marked. We'll put one cell inside this cabinet and put the charge controller inside here as well. And then I'll have a self-contained stereo Bluetooth speaker. Once again, I will snip the metal tab, separate the batteries, make sure that we don't cause a short circuit here in the process as well. Okay. Of course, the problem with this is, with these tabs, is that if you're not careful, this is the positive terminal, this one's the negative terminal, but on this other one here, this one here is the positive terminal of this cell. So if you're not careful and you nick the casing like that, you could cause a short circuit when you're dealing with these batteries. So you got to be kind of careful. I'm going to keep the tabs bent away so that they aren't going to be in any way possible to contact and cause an internal short. Normally what I do with these cells is I rip the ends off them, and then I can use them in my battery charger and use them in my my flashlights and stuff. And I've got a few. I've got enough cells to power up all my flashlights for a while. So now I've got 4 more of these cells. So one of them is going to go, this one is going to go inside this cabinet here. And the reason I've left the tabs obviously on here is so that I can solder down to them, because it's a little more difficult to try to solder down right to the battery. These are actually spot welded on. So we'll undo the lid on these most awkward of project cases to put together. There we go. I don't have a lot of room in this thing. I didn't leave myself a lot of room on the wires, but I don't need much. I just need to be able to attach the battery here, attach the charger. So I'm going to hot glue this thing on, I think. I'll use some hot snot and I'll put this thing on like this, so that this is accessible to plug a charge cord in. Let me just find a charge cord that I can make sure it'll plug in. So this is stuck like that. Easier said than done. I did mention that I didn't leave a lot of space on the yeah, will that plug in or not? Yeah, it should plug in. I should be able to plug that in if I glue this down. If I glue this down to this cabinet like that, I should be able to plug the cord in. I just don't know whether I should use epoxy or hot glue. Hot glue might not stick properly, so it might be better to use epoxy to glue this in place. That way, to charge it up, you just plug in the charge cord. And actually that might be the way to glue it, is to have the charge cord plugged in so that it'll hold it in place while the glue sets. That might be the best way to do it. I think that's what I will do, is I'll leave it plugged in. I decided to use the hot snot dispenser instead, just because it's faster and it should do the job, and I don't have any epoxy, so I just went to grab some epoxy and found out that, well, the epoxy is empty. So hopefully this will be able to hold this in place. I'm sure it will. This is pretty strong stuff. If I get enough around the board here, when it sets up, this should, I would think, hold this in place. The nice thing about using hot glue is, of course, it sets up as soon as it cools down. You don't have to deal with waiting for it to cure. It's cured immediately. I just hope I didn't get any on the connector and actually glue the connector into the fitting. That would be a disaster if I ended up gluing that in, but we'll find out pretty quick. This stuff's getting setting up pretty good here. I'll give it another 5 minutes or so. Let it cool down completely. Okay, I think what I'll do is I'm going to solder the positive terminal of this battery, which is this one here. I'm going to solder it directly to the tab of the power switch. That way that'll hold that physically in place, and then I'm going to put some glue underneath here to glue the rest of the cell down. And then my negative terminal will be accessible to connect the negative terminal to the charge and so forth. So if I connect the positive terminal here, then I just have to connect this positive wire over here to the charge positive, and the negative going back to the cell. So I'll solder my positive terminal directly to the switch. Now, don't worry, I am going to be putting fusing on this thing. I'm not that stupid. I have a little 1 amp fuse here that I took out of the other power supply, which will be the fusing. It'll go on the negative terminal, so that if there was any catastrophic short, it'll just pop that fuse. Because of course a lithium cell's got a lot of energy in it, so you don't want to have a failure. Especially in a plastic box, it could go up like a tinder box. So We'll solder the positive terminal directly to the switch here. And then I can use some hot glue to actually glue the cell to the cabinet so that the battery itself will sit inside the cabinet. There should be enough room in here, I'm thinking. Let me just see, make sure this thing's going to actually close up once I get this in place, because I didn't consider that. There might not be enough clearance. It should fit in there. Well, this is exactly why it's always a good idea to check things out before you complete the job, because I found out that no, that's not going to work. That speaker magnet's in the way. I'm going to have to relocate the battery. So I think I will relocate the battery to the top, and we'll put it over top of the speakers. So what I'm going to do is I'm going to relocate the battery to the bottom. I've put a negative terminal onto here and fused my negative terminal. The positive terminal will solder onto here, and the battery itself, I can slide it right into the bottom of the unit like this, like that. Now I'm going to insulate this full negative terminal with a piece of tape, just so that if it ever were to get turned around, it couldn't short out to anything. So we'll just put a piece of tape around here, covering, including the fuse. So this, now the entire unit can be slid in the bottom. That way I've got enough clearance, and then all I have to do is connect the positive terminal up to my battery and to my switch, and that should complete the project. Now, will this fit in here now or not, or am I still going to have some clearance issues? That's what I'm looking at here. Yeah, this should fit in here now. So I'm just kind of fitting it in here now before I hook everything up. But I should have enough room that should fit. Hopefully that will fit there. Otherwise, my other option is to put it over top of the speaker, which is another option. Just want to see whether it'll fit. No, it looks like I'm going to have some clearance issues for my charge port. So I can take the battery on the top up here, and it'll fit wedged in here between the speakers. I won't even need to glue it, because it'll actually be wedged right into the cabinet. It's not going to go anywhere. And I've insulated it so that the negative terminal isn't going to touch against anything. So I think that's where the cell is going to have to go, is it's going to have to go in the top, like that. But it'll rest between the two speakers here, so that'll hold it in place. And we'll just put a bit of glue in here just so that it doesn't move. Put some hot glue in here, just around onto the speaker magnet, just to hold it in place. But that, I think, is where it's going to end up being. Also, the magnets attract it, so it kind of sticks to the magnets anyway. So that will work. I'm just going to extend my power lead here, because when I put this thing together, it was such a short lead that it's really difficult to connect it. So I'm just going to use a little longer wire to connect my Bluetooth board and connect it up to the switch, and then from the switch over to the battery itself. So we'll just take this positive terminal off here, if we can, and put the new one on. Now I just need another wire. So I've got another wire here for my battery. We'll just connect that one to the switch. And the other side, make sure the switch is off before I start this. I don't need the thing beeping at me when I hook this up. Okay, now when I turn it on, it's ready to go. Let's put the battery in place. Put some hot glue in there to hold it in place so it's not going to move. And put the unit back together. So there's the battery, and there's some hot glue. That will hold it. I know, I just scored about 10 thumbs down for using hot glue, right? Because we know how people feel about hot glue. Hey, it's quick and it's easy and it's relatively strong, and it will do the job to hold this battery from moving around. Couple screws into it. And the other two. I hate these type of cabinets, by the way. They're just a pain to put together. But if you're careful, you can get them without too much trouble. It's kind of an art to it. Okay, that's one. And the last one. And I'll plug this thing in and make sure that it goes into charge. Okay, that's that. I have my charger here somewhere. Okay, I got a USB charge cord here. It should light up when I charge it, by the way. It should light up, I think it lights up red when I charge it. Yes, it does. There's a red light flashing there to indicate that the cell is charging, and when this light stops flashing, the cell is fully charged. Now I could have connected this, instead of going right to the battery, I could have connected it through because this has got a 5-volt supply, and I could have just as easily connected the battery to the charger and connected the speaker to the 5-volt supply. Now the main reason I didn't do that and I went straight to the battery was because this set of speakers, if you crank the volume up, will exceed the power capacity of that little boost converter. It's only a 1 amp charger, and this thing, if you crank up the volume, will draw more than an amp, which will cause that power supply to shut down and reset. So I took it right to the battery terminal as opposed to using the boost converter. Anyway, that's it. Project's all done. I don't have a link up for this particular Bluetooth board because I have reviewed this one before, and the link is in the original review. But if you want it, I will find the link for it and put it up if you're wanting to know where I got the Bluetooth board. It's one of the projects that I got from IC Station there over the last year or so. Both the speaker box, which originally was a wired speaker with a 3.5 plug on it, and the little box, and of course the Bluetooth board itself, but it's got its own amplifier. Anyway, thanks for watching. We'll catch you in the next one real soon.